Welcome students. Today we are discussing an important topic of calculus, that is improper integral. So first we will understand what is an improper integral. As we know that if we have a function f(x) and we have to integrate this function from a to b, then if a and b are well defined, then it is known as proper integral. If we have limit like this a to infinity fx dx, here this limit, the upper limit is infinity, so we will say this integration as a improper integral because the limit is here, upper limit is infinity. So we will write this as limit. We will introduce a new variable, that is t, and this tends to infinity. Then we will write a to t fx dx. If this limit exists, then this is known as convergent. Okay. And if this limit does not exist, then it is known as divergent. So this type of improper integral is known as type 1. Okay. The other we can also write this way: minus infinity to a variable a, lower in limit is minus infinity and upper limit is here a. So here also we have minus infinity, so we will write this way: limit t tends to minus infinity, and this is t to a fx dx. The other case is here both the limits, means upper and lower, is basically from minus infinity to infinity fx dx. Then we will write this way: limit t tends to minus infinity, and we will take a point, or we will take a point in the domain of fx. Suppose this point is 0, and we will write this way: t to 0 fx dx plus limit t tends to plus infinity and 0 to t fx dx. So in this way we have three types of problems where the limit is basically from minus infinity 0 to a to infinity, then minus infinity to a, and minus infinity to infinity. If the limit of this minus infinity to infinity means if it is convergent, then it has to be convergent, this part has to be convergent, this part has to be convergent. It means that the limit of this part will exist and the limit of this part will also exist. Then we say that this is convergent. So for this to be convergent, it has to be convergent, and this one also. Now we will take an example and discuss this. So this example 1, here we are taking, suppose we are taking lower limit as 1 and this upper limit as infinity, and we have to integrate this. So here we have limit, lower limit 1 to infinity, 1 upon 1 plus x square dx. We have to find the value of this. So we will find the limit of this actually. We will introduce a variable t, and t tends to infinity, and we will write 1 to infinity 1 upon 1 plus x square dx. As we know that the integration of 1 upon 1 plus x square will be equal to tan inverse x. So limit t tends to infinity and we will write as tan inverse x 1 to t. Now we will write as tan inverse t minus tan inverse 1. So now putting the value of this t tends to infinity, we know that tan inverse infinity, it means when t tending towards infinity, then this value tan inverse t will be tending towards pi by 2. And when this is here tan inverse 1, that is equal to pi by 4. So answer of this is will be pi by 4. So limit exists and the value of limit is pi by 4. So this is the type 1 improper integral, and we have discussed the example 1 here. Now let's take another example. Here we will take the function fx equal to e raised to power x. So suppose in this case we have to minus infinity to 1, and we have a function e raised to power x dx. So this will be basically limit t tends to minus infinity and we have t to 1 e raised to power x dx. So as we know that the integration of e raised to power x dx will be e raised to power x, and we have a limit here, we will put minus infinity e raised to power x, and we have lower limit t, the higher limit 1. So this will be limit t tends to infinity e raised to power 1 minus e raised to power t. So as we know that if t tending towards minus infinity, then e raised to power t will be tending towards 0. So e raised to power 1 is same, but this will be 0 and the answer will be e raised to power 1. So this improper integral limit is e raised to power 1. Now we will discuss another example. In this case, we will take the value, or the lower limit is minus infinity and higher limit is infinity. Now we will take the function as 1 upon 1 plus x square dx. So here this is similar to this we have discussed earlier, this minus infinity to infinity fx dx. Then we have to break this into two parts. So first we will take this minus infinity to 0 and then 0 to plus infinity. So same we will follow here. Okay, then we have to write this way, limit t tends to minus infinity, and we will write this way t to 1, because 1 is the domain of this function, is the part of the domain basically, 1 upon 1 plus x square dx, then plus a limit t tends to plus infinity and 1 to t, lower limit is 1, higher limit is t, 1 upon 1 plus x square dx. So we have taken a point 1 and minus infinity to 1, we are going this way, then 1 to infinity. So this has, if this is convergent, it means this limit has to exist, and the same time this limit has to be exist or convergent. So we will write this way, and we know that this will be equal to tan inverse x, and limit will be, lower limit is t, higher limit is 1. Again here t tends to plus infinity, and this will be tan inverse x, and lower limit is 1 and higher limit is t. So this will be limit t tends to minus infinity, tan inverse 1 minus tan inverse t. So now another part is plus limit t tends to plus infinity, tan inverse t, because higher limit is t, and minus tan inverse 1, lower limit is 1. Now we have this way. So this will be tan inverse 1 will be pi by 4, and as tan inverse t, when t tends to minus infinity, then it will tends towards minus pi by 2. Okay, plus we will put a bracket here. In another case we have tan inverse t, in this case tan t tends towards plus infinity, so this will come, this will be tending towards pi by 2, and another case is tan inverse 1, that will be pi by 4. So this pi by 4 and this pi by 4 will cancel out, and we have pi by 2 plus pi by 2, that will be equal to pi. So this is the limit of this function, and this is convergent. So in this way, this is the case we have discussed here, and this all are belongs to type 1 category. Now we have another type, that is known as type 2. Improper integral of type 2. Type 2, here the limit, basically suppose this, we have a limit a to b and fx dx, but in between a and b, okay, in between a and b there is a point c, suppose, and at this c this function is not defined. So fc is basically not defined. So this is known as type 2 improper integral. Means here this point is in between, or means suppose this is a and this is b, and we have a point, suppose here it's c. So this point, at this point, this function fx is not defined. So we will break this up to, as we know, so we will break this as limit c or t tends to c minus, basically this way, a to t fx dx plus limit t tends to c plus. So this will be c to b fx dx. So to solve this, we have to, this limit has to be exist, means this and this. So this type of function will fall in the category of type 2 improper integral. Okay. Suppose I will give you an example of this is, suppose this we have function is basically fx equal to 1 upon x square. Okay, and we have to integrate this function from -1 to 1. Okay, so as we know that this function fx will not exist, or it is not defined at x equal to 0. Basically at x equal to 0 this fx is not defined. Okay, so this is the category, and this 0 value means at x equal to 0 is in between -1 to 1. So we will write this way. So we will solve this way, means we will introduce a variable t, that is 0 minus. Okay, so lower limit is -1 to t fx dx plus limit t equals to 0 plus. So we are not at 0, we are at 0 plus or 0 minus. This will be t2 1 fx dx. So in this way we will check the limit or calculate the limit of this, and if this exists then it is known as convergent, otherwise it is divergent. So if this value has to be convergent, then this limit has to exist, and this same time this also. So we have taken example fx equal to 1 upon x square. So let me solve this, and -1 to 1 upon x square dx. So we will take a variable t, that is t tends to 0 minus, and this will be -1 to upper limit t 1 upon x square dx plus limit t is 0 plus. So we have t to 1 upon x square dx. Okay, then we know that this we can calculate, and this will be t minus, and this will be -1 by x, and lower limit is -1 and higher limit is t. Same, limit t tends to 0 plus, this will be -1 by x, and lower limit is here t and higher limit is 1. Now we will put the value, limit t tends to 0 minus, so -1 by t and -1 by 1, that is 1. Okay, same, minus limit t tends to 0 plus, and this will be -1 minus 1 upon t. Okay, so as we know the value of this limit, if you are putting 0 here, then this will be 0 minus h, some quantity, and the same will be here, minus plus. So minus, and this will be like this one, means 0 minus h. Okay, this quantity plus 1 plus, this is -1, this will be plus 0 plus h. this will be minus minus plus 1 by h, and it will cancel out. This will be 1 by h. Okay, so in this way we have found that this limit comes infinity, so this is not convergent. So in this way we will find the solution of type 1 and type 2 improper integral. So till then, bye bye, take care.